There were several questions in class on homework from 5-6 exponential equations that I was unable to answer because the videos for 5-8 and 5-9 took up the majority of class time. So this video covers solutions to 51, 59, 61, 67, and 89. That way we can spend more of class time on Friday reviewing for the midterm. 51. 3/5 to the x equals 7 to the 1 minus x. So I am going to take the log of both sides. I think your book uses natural log, doesn't matter. So I'm going to take the log of both sides. And as the instructional video showed, you can add 6 to both sides. You can divide by 23. You can square both sides, where you can actually take the log of both sides. So this becomes the log of 3/5 the x, and that's going to equal to the log of 7 to the 1 minus x. Bring the x down in front. This is x times the log of 3/5. And that equals parentheses 1 minus x times the log of 7. I'm going to go through these kind of fast, and you can obviously pause along the way. I need to get all the x's on one side. So this is going to be the log of 7 minus x times the log of 7. And this is x times the log of 3/5. Put all the x's together on one side and the constants on the other, so that way you can factor out an x. So I'm going to add x times the log of 7 plus x times the log of 3/5, and that's going to equal the log of 7. Factor out the x. Divide both sides by the log of 7 plus the log of 3/5, and I believe that we will end up subtracting the logs. The log of 3/5 is the log of 3 minus the log of 5. I'm going to divide both sides, and that's the log of 7 over the log of 7 plus the log of 3/5. Excuse me. I'm not sure how your book writes it. I mean, this is okay. It's not very clean. So I'm going to write this as the log of 7 over the log of 7. Don't you dare cross those off. It's so voodoo math. Plus the log of 3 minus the log of 5. And I'm going to leave my answer like that. Your book may have used natural logs. You should still get the same answer with natural logs as opposed to quote unquote regular logs. Next, we're going to do 59. 59 is definitely funky. So 59 says 3 to the 2x plus 3 to the x plus 1 minus 4 equals 0. Okay, little side note. This is going to matter big time. 3 to the x plus 1 is the same thing as 3 to the x times 3 to the first. This is the key to the problem. Multiply terms, add exponents. So when I multiply 3 to the x times 3 to the first, I end up with 3 to the x plus 1. So this is now 3 to the 2x plus 3 to the x times 3, and then minus 4 equals 0. Okay, well, I can factor this actually. We can factor this. 3 to the 2x is 3 to the x times 3 to the x. So I'm factoring this. 3 to the x times 3 to the x is 3 to the 2x. Minus 1 plus 4. So I factored this. Distribute 3 to the x times 3 to the x is 3 to the 2x. This is plus 4 times 3 to the x. This is not 12 to the x. So this is plus 4 times 3 to the x minus 1 3 to the x, which is positive 3 to the 3x minus 4. Zero product property. So you get 3 to the x minus 1 is 0. 3 to the x plus 4 equals 0. 3 to the x equals 1. X is 0. This is 3 to the x equals negative 4. Not possible. It's impossible to raise 3 to a power and get a negative answer, let alone negative 4. So the answer is indeed x equals 0. You could, if you wanted to, do a substitution. So you could have said, let y equal 3 to the x. So therefore, y squared would be 3 to the 2x. Square both sides, you get y squared. 3 to the x squared is 3 to the 2x. And you could have done this a substitution and said, okay, this is y squared plus 3y minus 4 equals 0. This factors as y plus 4, y minus 1. This gives you y equals negative 4 or positive 1. So now I've solved for y, but y is really 3 to the x. So then I would say 3 to the x equals negative 4. 3 to the x equals 1, which you can see I have right here. So it might be easier to do the substitution. Same answer either way. Which way is better? It makes no difference. You should do it whichever way makes most sense to you. Okay, 61. One says 16 to the x plus 4 to the x plus 1 minus 3 equals 0. This is very, very close to number 59. This is 4 to the 2x. This is 4 to the x times 4. How do you get that? 4 to the x plus 1 is 4 to the x times 4 to the first. When you multiply terms, you add exponents. So this becomes x plus 1. You can factor it from here if you want, or you can do the substitution. So I'll do the substitution. My instincts tell me that this is probably the easier way for you. So if y is 4 to the x, therefore y squared is 4 to the 2x. So this becomes y squared plus 4y minus 3 equals 0. Yeah, this is definitely the way to go because this isn't factorable and I need to use the quadratic formula. Okay, so quadratic formula I'm gonna skip a bunch of steps. I know that you know how to plug into the quadratic formula. You do your simplification and you end up with y equals -2 plus or minus √7. I'm gonna skip those steps. Quad formula. That's what y equals. Well, y is really 4 to the x. Y is really 4 to the x. So 4 to the x equals -2 plus √7. And 4 to the x equals -2 minus √7. Okay, so this is where if you know your properties, you're going to save yourself a ton of time. This is negative. -2 minus √7. This is some negative number. No can do. I know that -2 plus √7 is some positive number. √7 is, I don't know, 2 point blah, blah. It's more than -2. I don't care exactly what that number is. I just know that it's positive. So switch it to log form. And you get the log base 4 of, use parentheses, -2 plus √7 equals x. Okay, the next question I believe was 67, and 67 is just like 59 and 61. So if you had a question on 67, I would recommend that you pause the video here, do the problem, and then come back and check my work. So 67 says 4 to the x minus 10 times 4 to the negative x, that equals 3. So I'm going to say let y equal 4 to the x. So this is going to become y minus 10 times 1 over y. And that's going to equal 3. If y equals 4 to the x and you raise both sides to the -1 power, you get y to the -1 equals 4 to the negative x, and y to the -1 is 1 over y. Y to the -1 is 1 over y. So 4 to the negative x equals 1 over y. Multiply both sides by y. So that becomes y squared minus 10 equals 3y. Set it equal to 0 and use the you have to use the quadratic formula because this is not factorable. It is factorable. This is y minus 5, y plus 2. I was doing the quadratic formula off to the side and the discriminant was a perfect square. Let's just do a quick double check. Plus 2, yeah. So y equals 5 and -2. But y is 4 to the x. So 4 to the x equals 5. That's doable. 4 to the x equals -2. That is not doable. I wish I could tell you there's a pattern. When the problem looks like this, there's one solution. When the problem looks like this, there's no solution. But there's really no set pattern. So this becomes the log base 4 of 5 equals x. I will ask you to leave your answers. If a problem like this is on the midterm, I will ask you to leave your answers in exact form. Last problem is, last problem that you asked to see was number 89. Follow the hint they give you. Follow the hint they give you. Okay, so I'm pretty positive that I did a problem almost identical to this in the notes. This is fuzzy. Yeah, that's much better. Okay. What number am I doing? 87, I think. Sorry, I lost my train of thought here. Which one am I doing? 89. So 89 says e to the x plus e to the negative x over 2 equals 1. Multiply both sides by 2 for sure to start off. This looks really similar to the problem I just did right here. Right, you've got a 4 to the x, a 4 to the negative x equals a constant. They look almost the same, with different base, different base. So the book gives you a hint and says multiply each side by e to the x. So I'm going to just do a substitution. I'm just going to do a substitution. It will work the same way. So if y equals e to the x, then y to the negative 1 equals e to the negative x. Raise both sides to the negative 1 power. Y to the negative 1 is 1 over y. And again, this really is identical with, okay, not identical, but different numbers compared to 67. So this is y plus 1 over y equals 2. Multiply both sides by y, and let's hope it factors. It might, I'm not sure. So this is y squared plus 1 equals 2y. It does factor. Hope I don't run out of room here. So this is y squared minus 2y plus 1 equals 0. This factors as y minus 1 quantity squared. Perfect square trinomial. So we get that y equals 1. With the multiplicity of 2, it doesn't hurt to review that, and it would bounce on the graph. If I were graphing y squared minus 2y plus 1. If I were just doing this part, I would have a bouncer. Okay, so y is 1, but y is really e to the x. And so therefore, x is 0. Those were the questions that were posted in InnoLecture. Hopefully this helps. Homework won't be due until Thursday though, because I didn't do it in class for you.